So next instruction set is the Boolean instruction set. Boolean instruction set is also called bit manipulation instructions. So these instructions will operate on bits of data. So other instructions what we discussed earlier will operate on bytes of data. Bytes of data means one byte. All of you know that one byte is 8 bits are called one byte. So here Boolean instruction will operate on a bit of data. So it operates on one bit of data. So the instructions in Boolean instruction sets are set, clear, complement, movement between a bit and carry flag, logical and logical or. So these are the Boolean instruction or the bit manipulation instructions of 8051 microcontroller. So let's see the instructions in detail. So already discussed that the Boolean instruction will operate on bits of data. So this is the structure of our internal RAM. So the internal RAM, the structure is from 00 hex to 2F hex, and we have 00 hex to 7F hex. So in the internal RAM, we have 16 bytes of locations are bit addressable location. That means each bit of this location has a unique address, so a specific address. So we can access each bit of this area with the help of this bit address. So Boolean instruction can be operate on this bit addressable area and also the special bit addressable special function registers. So we know we have 21 special function registers in 8051 microcontroller. In that, some of the special function registers are bit addressable special function registers. So you can see the one with the star here are bit addressable special function registers. That means it has separate address for each bit of the register. So the special function registers which are bit addressable are A, B, P, S, W, port registers P0, P1, P2, P3, TCON, SCON, IE, and IP are the bit addressable special function registers. So you can see that these registers, that is, let's take the example that is the accumulator register. The accumulator register has an address E0. So when we give the address E0 for a byte instruction, it accesses all the 8 bits together. So for byte operation, we uses E0 address. Also, each bit of the accumulator has address that is E0 to E7. Accumulator register is an 8-bit register. So the address E0 to E7 is used for addressing the each bit of the accumulator register. So any bit of the accumulator register can be changed with the help of this bit address. Likewise, all these special function registers, each bit can be all the bit addressable special function registers, each bit can be addressed with the help of accessed by the special address, the bit address. So we have a few instructions that operates on the carry flag. So the first instruction is set BC. Set the carry flag. This is to set the carry flag. So example, we write the instruction set BC, that is the carry flag will turn to 1. So the whatever the value in the carry flag, it is changed and the new value that is 1 is loaded to the carry flag. So this instruction is used to set the carry flag. This makes the carry flag 1. Number of cycles required is 1. So next is to clear the carry flag, CLRC. CLRC will clear the carry flag. It gives a value 0 to the carry flag. This instruction is used to clear the carry flag. This makes the carry flag 0. The number of cycles required is 1. Next is complement. This will CPL, that is complement instruction, CPLC, that is complement the carry flag. So complement the carry flag means the carry flag will get the complement of the previous value in the carry flag. So if the previous value in carry flag is 1, it is complemented to 0. And if the previous value of carry flag is 0, that is complemented to 1 while using after performing this instruction CPLC. So whatever the value in the carry flag, it gets complemented. This instruction is used to complement the carry flag. This makes the carry flag the complement of the carry flag. Number of cycles required is 1. So set, clear, and complement are operations on carry flag. Next is set B. Set B, B. B means bit. So B represents any bit from bit addressable area of the internal RAM having bit address 00 hex to 7F hex. So it is from the bit addressable RAM space. So you have seen the bit addressable RAM space is 20 hex to 2F hex. This is the byte address of this area. We have 16 bytes are allotted for bit addressable area. So in each byte contains 8 bit. So the 20 hex, the byte address contains 8 bit, and the address of each bit is 00, 01, 02, 03, 04, 05, 06, and 07. Likewise, the byte address 21, the location, byte location 21 contains 8 bit, and it's given the address from 08 to 0F. So we have 16 byte location. So we have address 16 into 8, that is 128 bit locations are available in this area. So the address given to the bits of this area, that is 00 hex to 7F hex. So the bit here represents any area, bit here, the area from the internal RAM having bit address 00 to 7F. So any bit from this part can be used as the bit here. B can represent any address from 00 hex to 7F that will be pointing to that location, the 16 byte bit addressable location of the internal RAM. So, or the B also can be any bit addressable special function registers like PSW register or port register, etc. So PSW 0.3 or P0.7, etc. So any special function register can be mentioned here to represent the B. So example, you can see the example, that is set B P0.2. So this will set the port bit P0, port 0, say, second bit to 1. So this bit will be set to 1. So set B P0.2, that changes the value in P0.2 to 1. So set B 00 hex, the bit location 00 hex of the internal RAM gets the value 1. So we have seen the bit location of internal RAM, that is here we have the bit location, that is 00 hex. This is the bit location 00 hex, and this is the byte location 00 hex. So this bit location 00 hex is set. That means the value will be set to 1. This instruction is used to set any bit B. It can be a bit from bit addressable area of the internal RAM having address 00 hex to 7F hex, or it can also be a bit from a bit addressable special function registers like TCON 0.4. TCON 0.4 means the fourth bit of TCON register. So the number of cycles required is 1. Next is clear instruction, clear the bit. As we said about the set instruction, the clear instruction will clear the particular bit. So clear P0.2 will clear the port 0 second bit to 0. So clear 00 hex, the bit location 00 hex of the internal RAM gets the value 0. The instruction is used to clear any bit B. So it can be bit from bit addressable area of internal RAM having bit address 00 hex to 7F hex, or it can also be a bit from a bit addressable special function register. Next is complement the bit. So complement bit CPLB. So CPLB, CPL P0.2 will complement the port 0 second bit. So whatever the previous value, it gets complemented. So CPL 00 hex, it will complement the bit location 00 hex, not the byte location, bit location 00 hex of the internal RAM. This instruction is used to complement any bit. It can be a bit from the bit addressable area of the internal RAM that is having address from 00 hex to 7F hex, or it can be a bit from any of the bit addressable special function registers. So here, next is move instruction. So move instruction, it's a data transfer instruction that is moving from one place to another. So here we are moving, here you can see move C comma B, that is the first one. C is the destination and B is any bit from the bit addressable location or any bit from the special function register, bit addressable special function registers. So example, move C, move a bit into the carry flag. This is to move a bit into the carry flag. Carry flag is the destination and B is the source. So move C comma P0.2. So the bit from P0.2 is moved to carry flag. So carry flag will get the value from P0.2. So whatever the value in P0.2 is copied to carry flag. Move C comma 25 hex. This 25 hex will represent the bit address 25 hex location. So bit addressable space of the RAM, there the address 25 hex. So from there we are moving to the carry flag. So you can see that moving to carry flag means we are moving only a bit. Carry flag can hold only one bit. So we 25 hex, we have 25 hex byte location and 25 hex bit location. So here the 25 hex means the bit location, because here we are moving to carry flag. The carry flag hold only one bit. So only one bit can be copied to carry flag. So this will be the bit location. So from bit location 25, whatever the bit in this location is copied to carry flag. It may be 1 or 0. So that will be copied to the carry flag. So the carry flag will get the value from the bit location 25 hex from the internal RAM. The instruction is used to copy the value of some bit into the carry flag. It can be a bit from bit addressable area of the internal RAM that is having address from 00 hex to 7F hex, or it can also be a bit from a bit addressable special function register like tcon.4, scon.4, scon.3, and any bit addressable special function register. So this is a clear difference. There is a clear difference between the following two instructions. So we have seen the instruction move a comma 25 hex. This refers the byte location 25 hex, because a register, it's an 8-bit register. So we are copying to, when we are copying to moving to a register, we are moving 8 bits at the same time. So it's moving a byte. So here the 25 hex means the byte location 25 hex. So 8 bits of data is copied to a register, accumulator register. So here you can see move C 25 hex. Here the 25 hex refers to bit location 25 hex, because C register, it's a C flag, that is carry flag, is a 1-bit flag. So only 1 bit can be moved to carry flag. So here the 25 hex will represent the bit location 25 hex of the internal RAM. So move B comma C, move from carry flag into a bit. So here the bit location is the destination and carry flag is the source. So example, move P0.2 comma C, that is the P0.2 will get the value from the carry flag. So from carry flag we are copying to P0.2. The first one will be the destination, second one is the source. So here you can see move 25 hex comma C, that is 25 hex is the bit addressable location, gets the value from the carry flag. So from carry flag we are copying to the RAM location. This instruction is used to copy value of carry flag into some bit position. So it can be a bit addressable space of the internal RAM, or it can be any special function register, bit addressable special function register. The number of cycles required is 2. So here there is a clear difference between the following two instructions. Move 25 hex comma A. Here A register is an 8-bit register, so we are transferring 8-bit of data. So when we are transferring 8-bit of data, the 25 hex will be the byte location, refers the byte location 25 hex. So here this instruction move 25 hex comma C. Here C is 1-bit register, 1-bit flag. So this from this flag we are copying to bit location. So 1 bit of data is moving. So this 25 hex will refer to the bit location 25 hex. The next is the logic operations. Logic operation can be performed in byte of data and also bit of data. So here it operates on bit of data, ANL C comma B, that is and carry flag with a bit. So carry flag is 1 bit, so we are ANDing with a bit. B represents any bit from bit addressable memory location, internal RAM, or byte bit of a bit from the special bit addressable special function register. So example, you can see ANLC comma P0.2, the carry flag. The result will be stored in the carry flag. So likewise, we said for the byte operation, the logic operation, you will get the result in the A register. Here, when we are doing the bit operation, our accumulator is the carry flag. So the carry flag will get the result after the operation. So we are doing operations with carry flag and some other bit, and the result will be stored in the carry flag. So it is interesting to note that in bitwise operation, carry flag acts as the accumulator. So example, you can see ANLC comma P0.2. So here the carry flag C will get the value carry flag and P0.2. So let me draw and see that you will get a clear idea. So we have a carry flag here, and this is a P0.2. It will be so this is a byte location. In that we have the bit location, that is 25 hex. 25 hex. So let it be this, the 25 hex bit location. So some value will be here. The value in the bit location, that is 1 bit. 1 bit may be 1 or 0. Let it be 1. That is the in the 25 hex location. This is the carry flag, and this is P0.2. Let it be P0.2. For 0 bit, let it be 1. The value, the carry flag initially has some value. So here, ANL C comma P0.2. So that means the carry flag is AND with P0.2. Carry flag contains 0. So 0.1, you get the answer 0. And this answer will be placed in the carry flag. So the carry flag will get the value 0. So next, let's change the value. It will be 1. And the value in 25 hex location be 0, so that you get. So 25 hex location contains the value 0 and carry flag contains the value 1. So let's see the next instruction. ANLC, 25 hex, the carry flag C gets the value carry flag and 25 hex memory location. So carry flag, the value is 1.0. The value will be 0. So this 0 is placed in the carry flag. The carry flag will get the value, the content of carry flag and dot the value in 25 hex location. So you get 1.0, the 0 value is copied to carry flag. So this is used to AND the value of bit with the carry flag. The bit in a special function register or in a bit addressable memory location, it is ANDed with the carry flag and the result is stored in the carry flag. The number of cycles required is 2. So it is not that in bitwise operation, the carry flag acts as the accumulator. So here ANLC, bar B. So here we are taking the complement of what in so here we are taking the complement of the value in the bit. So ANDing carry flag with the complement of a bit. So here we are taking the complement of a bit, that is bar P0.2 means the P0.2 contains some value. It is ANDed with the value in the carry flag. So 0, here the operation that comes is the value in carry flag is 0 dot the complement of the value in P0.2, that is 0. So 0.0, you get the answer 0, and this 0 value will be copied to the C register, the carry flag. So next operation is also, that is ANLC, bar 25 hex. So that in second instruction, so you can write here the content of carry flag, that is 0 dot the complement of the value in the memory location 25 hex. So the 25 hex memory location contains the value 0, the complement of 0, that is 1. So 1 dot 0.1, you get the value 0 itself. So this 0, the result will be held in the carry flag. So this instruction is used to AND the value of carry flag with the complement of a bit. So next is OR operation, C, B, or carry flag with a bit. So example, ORLC, P0.2. Here the carry flag will get the result, that is carry flag or P0.2. So the carry flag, the value here, it is so for the first instruction, the carry flag, the value is C0 or the value in P0.2, that is 1. So the answer you get is 1. 0 plus 1, you get the answer 1. So this 1 is placed, the result is placed in the carry flag. So the carry flag, the value becomes 1. So next operation, ORL C, 25 hex. So ORing the value in the carry flag with the value in 25 hex memory location, bit addressable memory location. So to 25 hex, the bit addressable memory location, the value is 0. So 0 plus 1, you get the answer 1. And this result is stored in the carry flag. So this instruction is used to OR the value of bit with the carry flag. So here the next instruction, that is ORL C comma slash P, the complement or carry flag with complement of a bit. So here the first instruction ORL C contains the value 1. 1 is ORed with P0.2 bar P02 bar. So what is the value in P0.2? The complement of that is taken. So you get 1 plus 0, you get the value 1, and this 1 will be stored in the carry flag. The result is stored in the carry flag. The second instruction overall C comma slash 25 hex. So the value in C flag is 1 or with the complement of the value in 25 hex location. So the value in 25 hex location is 0. So the complement of 0 is 1. So 1 plus 1, you get the value 1. So this one result is stored in carry flag. So this instruction is used to OR the value of carry flag with the complement of a bit. So number of cycles required is 2. So let's see an example. Write a program to implement the following circuit. We have a circuit here, logic circuit and operation. We have OR operation, not operation, not we have, we don't have not operation. Instead, we are using complement operation. Complement operation can be used to get the NOT gate. And we have NAND. We don't have a NAND instruction, but we can do NAND by first doing the AND operation and then complementing the result. You will get the NAND. Similarly, you can get the NOR operation also. First do the OR operation and then complement it. You will get the NOR result. So here we have values A, B, C, D, etc. up to G, and we have two intermediate values. So we need two temporary storage space also. These labels, that is inputs, we are assigning